In 1964, Alaska was shaken by the largest U.S. earthquake ever recorded, magnitude 9.2. Shaking went on for over 4 minutes. 143 people died. Total property loss in 2013 dollars is estimated at $2.3 billion. There were gaping fractures, massive landslides, and the destruction of water mains, gas, sewer, telephone, and electrical systems. The epicenter was in Prince William Sound, 74 miles southeast of Anchorage, yet effects were observed as far away as Texas and Louisiana. What the 1964 Great Alaska Earthquake taught scientists was as profound and far-reaching. Initially, no one understood how or why the earthquake occurred. Immediately, 3 U.S. Geological Survey scientists were sent to figure it out. The scientists studied the effects from the air, on land, and along shorelines. They were astonished to find that the surface was disrupted over an area larger than California, 185,000 square miles. Some areas dropped down as much as 8 feet, and others rose up by as much as 38 feet. Barnacles, once 2 feet below the ocean's surface, were suddenly several feet above. Mapping this uplift and downdrop became crucial for understanding what happened. But with no faults visible at the surface to explain it, even with months of careful observation and fieldwork, the cause of the quake remained a mystery. Geologist George Plafker considered the quake in terms of this newly forming theory of plate tectonics. He knew the theory had new crust forming at mid-ocean ridges, but there was no explanation for where this crust went.
And so the most likely one that came to mind is that the oceanic crust is being pushed underneath that part of southern Alaska at a very low angle, and there was slip on the interface between the oceanic crust and the overlying continental crust.
These two crusts are converging at the rate of 1.5 inches each year. Periodic slip between the crusts produces great quakes, which Plafker called megathrust earthquakes. His realization changed our understanding of these great earthquakes. Megathrust quakes are the largest known on planet Earth. They occur in areas of colliding and descending crusts, known today as subduction zones. The uplift and downdrop of large areas from these quakes is a result of the crust being compressed over years of the plates converging. It releases like a spring, which is the earthquake. Seaward areas are uplifted, while landward areas drop down. George Plafker identified this pattern common to megathrust quakes in subduction zones.
The 1964 earthquake was the first megathrust subduction zone earthquake properly interpreted as such. As a result of that, essentially every other large subduction zone earthquake around the world sort of falls in the shadow of what we learned from the 1964 earthquake.
Next, the question became, how often do these quakes happen?
One of the obvious things that everybody wants to know when you have an earthquake like this is how frequently do they occur? Could you have one tomorrow, or is it thousands of years?
Plafker and his team drilled 50 feet into the earth and collected core samples to find out. They used carbon dating to identify when past megathrust earthquakes have occurred in south-central Alaska.
It's just an example of what has happened in the past, and the analog for that is what happened in the 1964 earthquake, namely an abrupt uplift of a broad area of mud flats that are intertidal, and then sudden appearance of freshwater plants growing on that surface.
In the cores, where the remains of land plants overlie ocean sediments, this marks a moment of sudden change, a past megathrust quake. Dating the plant remains provides an age for that quake. The team discovered 9 megathrust earthquakes have occurred in south central Alaska over the past 5,500 years. The average time span between these quakes was 630 years. Another devastating effect of the 1964 Great Alaska Earthquake was a series of deadly tsunamis. The largest, triggered by the shifting of plates when the quake began, traveled across the Pacific, wreaking havoc in coastal Oregon, California, Hawaii, and beyond. Locally, a number of extremely dangerous tsunamis occurred in south central Alaska fjords like Whittier and Valdez. Most deaths resulting from the 1964 quake came from these local tsunamis in fjords. The scientists recognized that these were produced by underwater landslides that occurred as the quake began.